are moving on to 8.2. In 8.2, we are going to be multiplying and factoring. All right, so we're going to start by talking about multiplying. Today, when we multiply, we are multiplying a monomial times a polynomial, which really means that we are going to distribute. When we distribute today, again, I want to remind you, we're going to multiply our coefficients then we're going to keep the base and add the exponent. All right, so this is how it's going to look today. Jumping right in with example number 1. Problems 10 through 14, where we're starting today. And it says simplify the product. Product means to multiply, right? Excuse me. So let's say I have 6x to the third times by 2x squared minus 7x. So we have a monomial in front of the parentheses of a polynomial, which means we distribute. So we're going to do 6x to the third times 2x squared. We multiply our coefficients, keep our base, and add our exponents. So we get 12x to the fifth. Then we're going to take 6x to the third times negative 7x. 6 times negative 7 is negative 42. We keep our base of x, and we add our exponent. 3 plus 1 is 4. Last thing we do is you should check to make sure that it's in the right order. So your highest exponent should always come first, and then go in descending order to your number, which this one is, right? This one wasn't so bad, huh?
If it was negative 42x to the 7th, then we could simplify it more.
Yep. All right. In that same example, let's do another one. What if you get a problem that's written like this? 3y to the third minus 7y squared, and then it's got times by 2y behind it.
Same thing.
It is the same thing. Remember, I want you to write that 2y in front, so we're just going to write it in front of it to begin with. And now we're going to distribute. 2y times 3y to the third. Multiply our coefficients, keep our base, and add our exponents. Again, remember there's a 1 on that y. So when we add our exponents, y to the first times y to the third, y to the fourth. 2y to the first times negative 7y squared. Multiply our coefficients. 2 times negative 7 is negative 14. Keep our base and add our exponents. Any questions so far? All right, let's go to example number 2 then.
Is it easier than yesterday?
I didn't think yesterday was tough, so I don't know how to answer that question. Okay, example number 2. Now, this one's going to cover 30 through 34 at the end. Say I want you to simplify And let's say I have 3x squared times 2x to the third minus 4 minus 2x times 5x to the fourth plus 7. I don't know. All right. So now we're going to start at the beginning. There's a monomial outside of parentheses, so we just distribute, right? 3x squared times 2x to the third. We multiply our coefficients, keep our base, and add our exponents. Then we have 3x squared times negative 4. 3 times negative 4 is negative 12, and we have x squared. We're to the end of the parentheses, so we're done distributing that one. We move to the next one. I have negative 2x times 5x to the fourth. We multiply our coefficients, that's negative 10, keep our base, and add our exponents. Then we have negative 2x times 7 is negative 14x. So now we check to see if our exponents are in descending order. I go 5, 2, 5. Uh-oh. What do you mean? This is x to the first times x to the fourth is x to the fifth. So now what are we going to have to do? Can't just switcheroo. What do we need to do? We have this 6. Yes, thank you. Add like terms. I have 6x to the fifth, and I have negative 10x to the fifth. Negative 4x to the fifth. Then my next highest exponent is x squared, so I have minus 12x squared. And then I have minus 14x. Questions? Do you want another example like that? Okay. All right. So then the other thing we need to talk about today is what this book calls factoring. When we are doing factoring, what I call it is undistribute. So we were just distributing everything into a parenthesis. What we're going to do is undistribute it out. So we're going to take what's in common and put it out. All right? So when we talk about undistributing, we are taking out the greatest common factor as a monomial in front of parentheses. All right, so what I mean is if I have 3x to the fourth plus 6x squared, first thing I got to decide is what is the greatest number I can take out of both of those terms. 3 is the biggest one. I can't take a 6 out of 3, right? I can take out a 3. This one has x to the fourth, and this one has x to the second. So what's the most we can take out? X to the second. I agree. All right, so then we're going to put our parenthesis. In this one, if I have a 3 times x times x times x times x, and I take out the 3 and 2 x's, what am I left with? X to the second, exactly, plus. Here, if I take out 3, what number am I left with? 2. And I'm taking out both x's, so that's all I have is a 2. So if I were to go back and just quickly check 3x squared times x squared, does that give me 3x to the fourth? 3x squared times 2, does that give me 6x to the second? Okay? So that's what we're doing next. Do we have a question? No? Okay. So here we go with example number 3. Example number 3 is going to be 16 through 20. States the greatest common factor. let's say I have 21 a to the fourth plus 14 a to the second plus, let's go with 28a. What is the biggest number I can take out of all three of those? 7, I agree. 7 goes into all three of those. How many a's is the most a's I can take out? 1. This one has 4, this one has 2, but this one only has 1, and I can't take more than what the lowest one is. So my greatest common factor is 7a. All you have to do for those. Do the rest of it, not for those couple of problems. You just got to find the greatest common factor. All right. Example number 4. This is 22 through 26. This says factor. What I will always say to you is undistribute. The greatest common factor. All right, so maybe you're given something like 4x to the third minus 12x squared. Yeah, let's just stop there. That's good. What is the biggest number I can take out, Ashton? 4, okay. What is the most x's I can take out? 2, so x squared. I'm going to draw my parenthesis. If I take out a 4 and 2 of the x's, what am I left with? Perfect, x minus, if I take a 4 out of 12, what am I left with? And if I take the x's all out, what am I left with? Perfect. All right, let's try another one underneath that. But we got to make it a little bit tougher because that was way too easy.
What if you would have done 3? What would have happened?
You can't take a 3 out of 4, so it doesn't work. Okay, that's a good question. Let's try this one. How about negative 10x to the third minus 5x squared plus 15x. Okay. I like the idea of taking a negative. We want our first term always to end up positive if we can. So let's take out a negative 5. I like that idea. And how many x's can I take out this time? All right, so I'm going to put my x. Then I'm going to put my parentheses. So in the first one, I'm taking out the negative, and I'm taking out a 5. What am I left with? 2. And then x to the what? 2, exactly. Okay, here I'm taking out the negative, and I'm taking out the 5, so I get a plus. X, very good. Now, here I'm taking out a negative 5, so what's the number here? Good. And I'm taking out the x, so I am done. And again, you can quickly check, negative 5x times negative 3, does that give me 15x? So we're good.
That's the only thing that's the same so far. It's like switching the
Just got to double check. Just multiply it back through real quick and make sure you're right. Okay? All right, let's do one more here, and then I have one last example, and I am done. No, crazy, right? One more. Let's do this. Let's go. 16 a to the fourth minus 8a to the third. Can we go anything bigger than 2? 8. I think we can take out an 8. All right, how many a's can I take out? 3 of them. Very good. All right. So if I take an 8 out, I'm left with 2. If I take out 3 a's, I'm left with? Good. Minus. If I take an 8 out, the 8's gone. If I take the a to the third out, that's gone. 1. That magical 1 has to be there no matter what. Okay? Hold on, I said one more example.
So how do you know whether or not to have an 8 or a negative 8 when you first?
Well, we want the first term, this one, to be positive. So if this one's negative, take a negative. If this one's positive, take a positive. Right. Yes. Hey, guys, I have one more example to go, or unless you want me to keep going. Off closed. All right, last example. Example 5. This circle has a radius of 6x. Inside the circle is a square mirror with one side 3x. It has this border around it. I want to know what is the area of the green border. To find that area, we are going to do the area of the circle minus the area of the square. Take the outside minus the inside. So, how do we find the area of a circle? Not circumference, that's the distance around. Area of a circle is pi r squared. Okay, wait a minute. And I know I'm recording, but so you guys never did the whole like nursery rhyme, fuzzy wuzzy was a bear. Circumference or area is no wait. Never did any of those? You guys knew circumference was 2 pi r. Right. Okay, so circumference is 2 pi r. Area is pi r squared. I'm not really sure what we learned last year. Okay. Yes. All right, focus. Here we go. Area of a circle is pi r squared. Area of a square is side times side, or side squared. Right? Because a square has same side, length times width, base times height. They're both the same. Okay, so we're going to start here. We have pi times our radius, which is 6x squared, minus the area of our square, which is 3x times 3x, or 3x squared. All right, so first we have to simplify the first one. I have 6x squared, or 6x times 6x, which is 36x squared, minus I have 3x times 3x, or 3x squared, is 9x squared. All right, so next thing I'm going to do is multiply my pi into this. It only goes into the first parenthesis. So I have 36x squared pi minus 9x squared. Okay. Is there something I can undistribute from both these terms? I can take out a 9. What else can I take out? An x squared. Very good. All right. So 36 divided by 9 is 4. And I take out this x squared, so I'm just left with pi minus. In this one, I'm going to take out the 9 and the x squared, so what am I left with? Perfect. This is exactly what you have to do for number 28. All right, so we are doing page 495, 10 to 34 even. You guys still have lots of time in class. You'll be surprised how quickly this is going to fly.